I'm Lindsay, and this is the lesson Everything Counts. In this lesson, students conduct a mini census to determine a building project that will meet the community's needs, and then use different estimation strategies to determine the building's impacts on the population of a threatened mouse species. This lesson is designed for middle school learners and has cross-curricular connections with science, math, and social studies. By participating in this lesson, students will be able to create a histogram to analyze collected census data, to simulate methods for counting wildlife populations, and to determine when it is appropriate to use each type of estimation strategy, and lastly, explain the importance of getting accurate wildlife counts. This lesson is broken into two parts. In part one, we ask students to imagine that they are a member of their local city council and that a plot of land has just been donated to the city. The city council decides to conduct a census of the community to help them decide what should be built in order to meet the city's needs. Students conduct a mini census of their schoolmates, their neighbors, or their relatives to simulate what this would look like. Using the provided student worksheet, students collect age data for 12 different households, and they must record their findings. After a few days of collecting data, students are asked to combine their data to create a histogram, which is similar in appearance to a vertical bar graph. Based on their data and their histogram, each student is asked to consider what type of building should be built and why, and what other types of data might be helpful to collect, as well as if they think their data is representative of the U.S. population as a whole. In part two, we ask students to imagine that they are ready to break ground on their building project. But unfortunately, they've learned that the building site is home to a large population of Preble's meadow jumping mice, which is a threatened species. Students must use different estimation strategies to try to determine the impact that the building will have on this threatened species. In order to complete this part of the lesson, students will be broken into small groups, and each group will need a cup of pinto beans, student worksheet 2, the provided habitat grid, and markers. Ask each group to scatter the beans on the habitat grid and explain that the habitat grid represents the site of the donated land and that each bean represents one mouse. In their groups, students use the worksheet to work through several different estimation strategies. So let's go through each estimation strategy in turn. We'll start with gross estimation. Just by looking at the grid, no counting, estimate how many beans do you think are on the grid. Next, we'll try a direct or sampling estimate. Rather than counting every bean, students use sampling to get an estimate. So how does sampling work? Well, students know that there are 100 squares on the grid. So they can find an estimate by counting the number of beans in, say, 10 squares and multiplying that number by 10, or 5 squares and multiplying by 20. Students are asked to choose 3 different combinations of sampling estimates and to record their answers. Lastly, we'll try a strategy called capture and recapture. And this is where things get really interesting. Students take on different roles. There's a timer, biologist A, and biologist B. First, biologist A collects beans one by one for 20 seconds. They count the number of beans they collected, record their total, and then mark the collected beans with a marker. Next, biologist B turns away from the group. No peeking. All the beans, including the marked ones, get put back in the cup, mixed up, and then rescattered on the grid. Biologist B then rejoins the group and collects beans again one by one for 20 seconds. Finally, biologist B records the number of total beans collected and the number of marked beans collected. Using this information, students can use the Lincoln-Peterson index and ratios to find a capture-recapture estimate. The Lincoln-Peterson Index works because there is a relationship between the amount of beans that are recaptured and the total amount of beans. If there is a lot of overlap between beans captured by biologist A and biologist B, in other words, biologist B has a lot of marked beans in their sample, the total population is relatively small. But if there is not much overlap between the two captures, the total population is larger. The lesson provides a number of different questions to help students debrief. For example, for each of these different estimation strategies, students are asked to consider how they would apply them to counting mice in a natural habitat, as well as some of the benefits and drawbacks to each strategy. Finally, based on their work, students must decide how many mice they think are actually living at the building site and ultimately decide what they would do with the donated land and explain why. If you're interested in other lessons related to census taking and counting populations, check out People Count for elementary learners and Family Counts for high school learners. For an elementary level lesson on estimation techniques, check out How Many Fish in the Sea. And for even more lessons, check out populationeducation.org. Thanks for watching.